So last time we stopped at the end of this problem and you're going to try wrapping it up. So let's go ahead and take a look at how to finish the problem together. So we got to the point where we had completed the square and we multiplied by 1/6 on both sides instead of dividing by 6 because it was easier to multiply by 1/6 when we had this fraction over here. Now we need to get rid of the square. So I'm going to take the square root of both sides. When I take the square root of the square and the square root cancel, and I have x minus 1/2. Over here, I have to remember that when I take the square root of a fraction, I'm really taking the square root of the top and the square root of the bottom. And I had to put a plus or minus in front. Now, kind of as a side note, don't forget that root 12 is root 4 times 3. The square root of 4 is 2, so this is 2 root 3. So now I can say x minus 1/2 equals plus or minus root 5 over 2 root 3. Now I do want to go ahead and rationalize this so that it's not quite so messy. And rationalizing means get rid of the radical. So that means I'm going to multiply by root 3, which is the denominator's root, on top and bottom. Now, a lot of times people multiply by 2 root 3, and that's okay to do that on top and bottom, but you can kind of ignore the 2 because it's not in the radical, so we don't need to get rid of it. So we have x minus 1/2 equals plus or minus root 5 times root 3 is root 15. I carry down my 2, and root 3 times root 3 is 3. So I really have x minus 1/2 equals plus or minus root 15 over 6. The last thing I need to do is move my x over. So x equals 1/2 plus or minus root 15 over 6. So don't forget, if you got a similar problem or a similar answer, but it wasn't rationalized, just make sure to rationalize your answer. All right, let's try a few more practice problems. Determine the constant that should be added to the binomial so that it becomes a perfect square trinomial, and then write and factor the trinomial. So in other words, I want you to try completing the square. Notice you're not solving, you are literally just figuring out what to add to it and then figuring out how it factors. Try it. Okay, so in this case, my b equals -1. b divided by 2 squared is therefore -1 over 2 squared, which is 1/4. So that's what I have to add to this to make it a perfect square trinomial. So that's the value. And if this were an equation that I was solving, I would add it to the other side as well. However, this means I just need to figure out how do I write this as something squared. Well, remember, we can do this two ways. We can either factor it by saying, okay, what two things multiply to 1/4 and add to -1? Or we can remember that if I have x squared plus bx plus b over 2 squared, that comes out to be x plus b over 2 squared. Now, I find that's an easier shortcut to work with for fraction problems. So in this case, I have my x. Since my b was -1, b divided by 2 is -1/2. So that's how it looks factored. Okay, quadratic formula. The quadratic formula is -b plus or minus the square root of b squared minus 4ac all over 2a. I know you're probably thinking you're going to get away with not hearing that again, but you are wrong. So remember, quadratic formula, you first have to make the equation equal to 0, okay? Then you're going to have to write x equals and start plugging your a, b, and c values into the formula. Give it a go. Okay, so first we subtracted 4x and we subtracted 2. Now I can write x equals, again, double check that you wrote x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Now, one of the places that I see people make the mistake most is b was negative 4. And if b is a negative, then when I ask for negative b, it swaps sign to become a positive. Also, when you're doing b squared, because b is negative 4, you have to put negative 4 in parentheses. So if you didn't put parentheses in, go ahead and add them now. All right, so that's 4 plus or minus the square root of 16 minus, well, it's going to end up being plus because I have a negative and a negative. 4 times 9 times 2, all right, once I put my negatives together and make it a plus, and that comes out to be 72. And it's all over 18. So it gives me 4 plus or minus the square root of 88 over 18. Now, some people might be tempted to stop here, but remember, we do have to simplify it if we can. So ask yourself, what perfect square do we know goes into 88? And if possible, what's the biggest perfect square? So if you're not sure, remember you can always make a chart. So I can break up 88. Oops, sorry about that. 1 and 88, 2 and 44, 3 doesn't work. 4 and 22, 5 doesn't work, 6 doesn't work, 7 doesn't work, 8 and 11, 9 doesn't work, and 10 doesn't work. So looking at this, the only, well, there are two perfect squares, 1 and 4. The big one in this case is 4. So root 88 is like root 4 times 22, which is 2 root 22. So I have 4 plus or minus 2 root 22, and it's all over 18, but I'm going to go ahead and split the fraction so that I can simplify each one. 4 and 18, 2 goes into both, so this simplifies to 2/9, plus or minus 2 goes into both 2 and 18, so this is root 22 over 9. Don't be tempted to simplify the 22 with the 18, because you can't do that because the 22 is under the square root, whereas the 18 is not. So they don't cancel at all. All right, let's practice calculating the discriminant. Remember that the discriminant is b squared minus 4ac. That's what's under the square root as part of the quadratic formula. Use the discriminant to determine how many and of what type solutions you have. So here, b squared minus 4ac is negative 18 in parentheses squared minus 4 times 1 times 81. 18 squared is, I think it's 324. Yeah, that sounds good. All right, and then 4 times 1 times 81 is, well, it's 324. Hey, look at that. So when I subtract those, I get 0. When my discriminant is 0, that means I have one real solution. Okay. Try solving this by any method that you like. All right, so first, you have to FOIL out the left side. So I have first is 2x squared, outside is 10x, inside is x, and last is 5, and it still equals negative 3. So 2x squared plus 11x plus 5 equals negative 3. And since it's a quadratic, I have to move everything to one side. So I'm going to add 3 to both sides. And that's going to give me 2x squared plus 11x plus 8 equals 0. So at this point, you can choose how you want to approach it. You can try to factor it. You can try to complete the square. or you can use quadratic formula. So remember, when your middle term is odd, completing the square is generally not going to be the easiest method. So I'd probably default to either factoring or quadratic formula. Now, not everything will be factorable, but if it is factorable, that's fastest. So it's probably worth doing a quick check of the asterisk. So a times c is 16, b is 11, a is 2. Can you think of any two numbers that multiply to 16 and add to 11? So I have 1 and 16, which is 17 when I add them. I have 2 times 8, which adds up to 10. I have 4 times 4, which adds up to 8. And that's it. So not factorable. Shucks. That means I have to do quadratic formula. So x equals, don't forget to write your x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So that comes out to be negative 11 plus or minus the square root of 121 minus 64 over 4, which is negative 11 plus or minus the square root of 57. Is that right? I hope so. I hope so. Over 4. Now, root 57 doesn't simplify, so this is the best I can do for my answer. All right, let's talk about Pythagorean theorem. Pythagorean theorem, if you think back in the day, is if I have a right triangle, okay, and I have one side A, one side B, then the hypotenuse is C, and a squared plus b squared equals c squared. So this question asks us to use the Pythagorean theorem and the square root property to solve the problem. They want us to express our answer in simplified radical form and also the decimal approximation. So note that it's asking for both formats, and we'll want to give it both formats. We'll also want to make sure we include units. All right, so I'm going to draw the picture for you, and then I'm going to have you try it. A rectangular park is 16 miles long and 8 miles wide. How long is a pedestrian route that runs diagonally across the park? Remember that rectangles have right angles. Okay? Try to find the length of the pedestrian route in both simplified radical form and in a decimal approximation to the nearest tenth. Okay, so I have 8 squared plus 16 squared equals c squared. And remember, since addition is commutative, if you did 16 squared plus 8 squared, that's fine too. Now 8 squared is 64, 16 squared is 256. I add those together and I get 320 equals c squared. Now I need to take the square root of both sides. Normally, when you take the square root of both sides, you're going to do the plus or minus in front. However, remember here that since we're talking about a length of a sidewalk, it can't be a negative length. So we're going to stick with just the positive value. So c equals root 320. Now, root 320 can be simplified. And so I'm thinking to myself, okay, what perfect squares go into 320? And can I think of any that are kind of a larger one? I may have to do it more than once, but let's see if I can't at least break it down to something not too ridiculous. So I say, okay, 320 is 1 and 320. It's 2 and 160. It's 3 does not work. 4 and 80. 5 and 64. And then I'm like, oh, that looks good. I like that one. That is a big number. That's a perfect square. So I'm going to use that. So I have root 64 times 5. The square root of 64 is 8. So I get that C equals 8 root 5. Now we're going to type that into our calculator to get a decimal approximation. And when we do that, we're going to get 17.8888, but it says to round to the nearest tenth. So if I have 17.8885 the nearest tenth means this spot here. Because the digit after it is more than 5, it does mean I need to round up. So instead of that, I'm going to have 17.9. So this is the simplified radical form. This is the decimal approximation to the nearest tenth. Note that in both cases, our answer should be miles. All right, great work.